content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. I'm really looking forward to tonight's discussion on an important topic, power source for fire pumps. Understanding reliable power. Here's a brief overview of what I will cover. In this episode, I will talk about the different power sources used for fire pumps and what is considered reliable power. I will give some common reasons why fire pump installation can fail inspection and rules needed to be followed to ensure safety and compliance. Additionally, I will share some practical tips to help you avoid these pitfalls, ensuring that your work meets electrical safety standards and pass inspections smoothly. Join me for valuable insight and easy to follow advice on securing reliable power for fire pumps. Let's learn more together. In many tall buildings and shopping centers, you might notice large red pipes and pumps in the stairwell or other locations. These eye-catching installations are fire pump systems, and they are very important for keeping people safe. These fire pump systems are not just there for looks. They are essential for protecting everyone inside the building. In fact, most of the time, it's not safe to have people living or working in these buildings without these fire pumps. Their main job is to quickly help put out fires before the firefighters arrive on the scene. It's important for professionals in fields like architecture, engineering, and electrical work to understand the rules set by the authority having jurisdiction and the National Electrical Code, especially when it comes to fire pump systems. These systems are vital for keeping people safe and protecting property during emergencies. By knowing the guidelines from the authority having jurisdiction and the standards from the National Electrical Code, these professionals can appreciate how essential fire pumps are for ensuring safety in buildings. What are fire pumps? A fire pump is a crucial component of fire suppression systems. It supplies water at high pressure, which is essential for making sure fire sprinkler systems, fire hoses, and fire hydrants work effectively during emergencies. Why are fire pumps required? In many buildings, the regular water supply isn't strong enough for firefighting. That's where fire pumps come in. They make the water pressure higher, allowing sprinkler systems to operate properly and put out fires more effectively. By providing this extra boost of pressure, fire pumps are vital in supporting firefighting efforts and improving fire safety for everyone. Let's begin. When it comes to fire pumps, ensuring they have reliable power source is crucial for their effectiveness during emergencies. Often, the authority having jurisdiction has encountered issues with major fire pump projects failing electrical inspections. These failures stem from misunderstandings within the electrical industry. To address these challenges, the authority having jurisdiction is proactively supporting the electrical industry by highlighting the importance of adhering to standards related to fire pump installations. The authority having jurisdiction aims to provide guidance to ensure the proper installation and functioning of fire pumps by reiterating the fire pump policies to the electrical industry. It is essential for all stakeholders in the electrical industry to be aware of and comply with standards outlined by the authority having jurisdiction to prevent future issues with fire pump installations. By working together and following these guidelines, we can enhance the reliability and performance of fire pumps when they are most needed. Now, I will read to you the policy on fire pumps from the authority having jurisdiction. To electrical contractors, power source for fire pumps. The concern: fire pumps supplied only by utility source. A fire pump supplied only by a utility source. That's a concern. This is not new. Concerns on this subject have not changed. Every few years, the authority having jurisdiction find installations where reliability was not considered. It was assumed with no supporting evidence. This situation is most always discovered towards the end of the project, which makes any changes costly and delays completion. Requirements. Article 695.3 of the National Electrical Code requires the power source to be reliable. 695.3A1 allows a utility service to be the sole source where it is reliable. The language requires that someone must evaluate the source and determine its reliability. The code does not define reliability. Therefore, the dictionary definition controls the meaning of reliability, and it is defined as unfailing. Reliability cannot be assumed. Electric utility sells electricity. During an outage, their product cannot be sold, and their customers are inconvenient. These are just two reasons why a utility strives for reliability. The St. Louis area is fortunate to be served by a utility that is responsive and forward-thinking. We enjoy great service, but the infrastructure is subject to acts of nature, people, and failed equipment, and all can have an influence on reliability. Reliability will not be the same for every location in St. Louis. Some areas have more outages and some have less. Determining reliability. The serving utility can provide an outage history report for a location. This report should be included when plans are submitted for a project with a fire pump intended to be supplied only by a utility source. If no outages are reported, one could conclude the source is reliable or unfailing. If plans are not required, submit the report without the permit application. If the report is not obtained and submitted as stated above, then an additional source of power will be required prior to a final inspection. So let's peel back the layers of the policy set by the authority having jurisdiction. Now, I would like to share a recent example of the challenges that the authority having jurisdiction face so that you can avoid common mistakes, keeping safety at the forefront of your work. Together, we can make safety a priority and help everything run smoothly during inspections. Before we get started, I just wanted to highlight the policy layers set by the authority having jurisdiction before we break it down. We have the concerns, diving into the risks of the fire pumps solely reliant on utility source. We have the requirements, unpacking the specific outlines in Article 695.3 for compliance and safety. Reliability check, highlighting why assumptions about power reliability can be precarious. Evaluation process, strategy for assessing and ensuring dependability of power sources. Also, seismic requirements for fire pumps. So I'm going to get started with the fire pumps supplied only by a utility source. The concerns about reliable electrical power remains unchanging over the years. It is not common for us to run across the authority to having jurisdiction to run across instances where the reliability was overlooked or assumed. This issue typically surfaces towards the end of the project, as I stated, leading to costly modifications and project delays. Here's the example of the job scenario. This is coming from the engineer of record to the authority having jurisdiction. Correspondence during the job when this incident happened. From the engineer of record to the authority having jurisdiction. My company is currently working on a project that involves installing a fire alarm system, and I am looking for information on a trustworthy power source for this equipment. The project has grown larger than expected, and now we need more detailed plans and guidance from your office. As the engineer of record responsible for this project, I want to clarify a few key points regarding our design. The revision includes a fire pump in our plans, and we are working with the utility company as our reliable utility provider. For the fire pump, we have set up a connection before the main electrical supply, as is standard practice in the industry and in line with safety and cost considerations. Importantly, the generator we have designed is not necessarily to support the fire pump. Therefore, our current layout does not include the fire pump being connected to both the main service and the generator. It only has the connection before the main switch. Do you agree with our understanding of this setup and our design choices? Your input would be greatly appreciated. I appreciate your support and collaboration. Response from the authority having jurisdiction. When thinking about backup power for fire pumps provided by utilities, it is important to look closely at how reliable the power supply is. This is not about blaming the utility company. Rather, it's about understanding the frequent power outages that can happen in the area. In St. Louis, the electrical system has its own set of challenges, mainly because it's old and can easily be affected by various factors like bad weather or wildlife. An example of this vulnerability is a recent accident power outage caused by a rodent getting into the transformer. This incident underscores why we need to pay attention to how reliable power, this incident underscores why we need to pay attention to how reliable the power supply is. The authority having jurisdiction connection with members of the code panel that set safety standards in St. Louis is very helpful. These people know the local situations well and can provide valuable insight into reliability issues. One effective way to back up any claims about power outages is to look at reports from the utility company. These reports can show us specific details about power interruptions in particular areas over the years. By reviewing this historical data, we can better understand how dependable the power supply really is. Being open to changing our views based on this information, especially from utility reports, shows our commitment to making well-informed decisions about the need for reliable backup power. It's essential to closely examine the history of outages to ensure that critical systems like fire pumps can operate safely and effectively. Response from the engineer of record to the authority having jurisdiction. The engineer of record, I want to give you an update on how we're wrapping up the service for our project. Here's a simple overview of what has happened so far. The recent changes made by the owner and what we discussed with the utility company regarding service interruption and possible updates to our permits. We received a permit to proceed without including a generator, since it wasn't necessary at the time. In the beginning of the job, it wasn't necessary. Since then, we have progress with the underground installation and laid out the project accordingly to the original plans. We have completed the inspections for this part, like the fire pump, and we have installed the necessary equipment. The owner later decided they wanted to add a generator for backup power, which requires us to modify the initial permit. Following your guidance and our discussion with the utility company, we took a close look at the power outages at this location over the past 3 years. Most of these outages, 7 in total, were short, lasting an hour and a half or less, and were mainly due to maintenance or minor line issues. There were a couple of exceptions caused by storms and some cable damage. Overall, we find that the power supply has been reliable. Considering everything we've done so far, the status of the project, and utility feedback, I believe we're in a good position now. I love to hear your thoughts. Please feel free to reach out if you want to discuss this further. Response from the authority having jurisdiction to the engineer of record. The authority having jurisdiction views your feedback as backing up the point we made earlier. The authority having jurisdiction understands that you want to broaden the definition of reliable, but the authority having jurisdiction prefers to stick with the traditional meaning, which is unfailing. 2025 NFPA 20 Standards for Installation of Stationary Pumps for Fire Protection mandates that the electrical fire pumps must be backed up by a dependable power source with no more than 4 hours of outage in the year before the installation. This reliable source can include a dedicated utility service, a dedicated feeder, or a on-site production facility. In cases where a reliable source is unavailable, an alternative power supply, such as a standby generator, may be necessary. The local authority having jurisdiction, we have enforced a stricter outage limit of 3 hours. That's in our policy. It is advisable to verify the specific requirements within your local authority having jurisdiction. Now, the takeaway from this scenario from the authority having jurisdiction policy, the concerns from that engineer, the importance of reliable power cannot be overstated. A 7-hour outage in the same year could risk the functionality of a system that is vital. It's crucial to remember that reliable power is defined by a dependable power source with no more than 3 hours of outage annually. Consistency and stability in power sources are paramount for operational efficiency and safety. He had a 7-hour, and the minimum is 3. By his own definition, that is against the policy. The reliability check highlights the assumption about power reliability can be precarious. Okay, the reliability reports are common reports for the authority having jurisdiction. The criteria for assessments are somewhat arbitrary, as they must be. It's not just about the number of outages, but also the duration and what caused the outage, whether it was equipment failure or weather-related incident. The evaluation of the reliability hinges on the energy delivery grid, performance, and related equipment like transformers. Outages beyond the utility control are not factored in the authority having jurisdiction outage decisions. exploring dependable power sources, strategies, and ensuring reliability. During construction, our project exceeded the original scope of work. So that's coming from the authority that's coming from the engineer of record. Exploring the dependability of power sources, strategy for ensuring reliability. So the the engineer of records, during the construction, our project exceeded its original scope, prompting the engineer of record to swiftly pivot towards enhanced plans and directives from the authority having jurisdiction. Adhering to the authority having jurisdiction guidelines, proactive measures were implemented to tackle and resolve unexpected challenges. A pivotal inclusion was the integration of a generator as a dependable power source to guarantee reliable power. To sum that up, the mistakes were made in the beginning. So now stay tuned as I explore the critical roles of the National Electrical Code, the standards in shaping unforeseen project expenses, as I dissect the impact of the National Electrical Code requirements on this undertaking. Stay tuned for insights on how these regulations influence the project financial landscape. When it comes to ensuring a reliable power source, it's critical to never assume the utility company has it covered. To assess reliability, requesting an outage history report from the serving utility for a specific location is key. This report becomes essential when submitting plans for a project that relies solely on a utility source to power a fire pump. However, unexpected challenges can arise, as highlighted by the engineer of record, stating the project has grown larger than expected, and now we need more detailed plans and guidance from your office. This unforeseen expansion of the project led to delays and increased costs, emphasizing the importance of thorough planning from the beginning. This situation underscores the significance of addressing concerns raised by the authority having jurisdiction regarding the risks associated with fire pumps dependent solely on a utility power source. Understanding how policies intersect with operational realities is crucial for ensuring safety and compliance. From the authority having jurisdiction, requirements, unpacking the specifics outlined in Article 695.3. For compliance and safety, requirements 695.3 of the National Electrical Code requires that the power source be reliable. 695.3A1 allows a utility service to be the sole source where it is reliable. The language requires that someone must evaluate the source and determine its reliability. The code does not define reliability. Therefore, the dictionary controls the definition. The meaning of reliable, as stated, is defined as unfailing. The authority having jurisdiction emphasizes the importance of dependable power source, particularly noting the criteria of reliability as stated in Article 695.3, while acknowledging that only a limited number of sites meet this standard. The authority having jurisdiction adopts a practical stance rather than a fault-finding one towards the utility providers. The prevalence of outages is a recognized reality, with certain regions experiencing them more frequently than others. Such occurrences are prevalent enough to warrant a dedicated website on outages by our utility provider, underscoring the necessity and of these disruptions. Article 695.6, power wiring. Power circuits and wiring methods shall comply with requirements in 695.6A through J as permitted in 230.98 and exceptions. Supply conductors, service and on-site power conductors. The point I'm getting to here, if you miss your chance to go underground when you're installing a fire pump, with the rules saying inside of a building, this is D, inside of a building where routed through a building, the conductors shall be protected from fire for 2 hours using one of the following methods. The cable or raceway is encased in a minimum of 2 inches of concrete. The cable or raceway is a listed fire-resistive cable system. The informational note also tells you the ANSA UL 2196 test for fire-resistive cables. Now, let's dive into the specific impact of the National Electrical Code standards for Article 695.6 on managing unexpected project costs. Earlier in this episode, the engineer of record highlighted that the project has surpassed its initial scope, necessitating a swift adjustment towards revised plans guided by the authority having jurisdiction. During the project early stage, an oversight occurred concerning Article 695.6A4A, specifically regarding the requirements to encase the cables or raceway in a minimum of 2 inches of concrete. With this avenue closed, the only remaining solution involves transitioning to an overhead approach, utilizing UL 2196 approved fire-rated cable manufacturer. When using an approved fire-rated cable, it's important to follow the installation instructions and guidelines carefully. That is crucial when you must use a system, electrical circuit integrity system. Doing so will ensure your project stays on track and avoid any necessary delays. Please make sure you read and follow those instructions to the letter. Seismic requirements for fire pumps. In areas that are at risk of earthquakes, it's important to protect fire pumps to ensure we can fight fires effectively. The authority having jurisdiction set rules to make sure that buildings and their systems, like plumbing and electrical setups and mechanical setups, can withstand earthquakes. By following some simple strategies, we can keep these systems safe during earthquakes. When we take these precautions, fire pumps will work properly, even when the ground shakes. This means we can respond to fires quickly and effectively, no matter what happens. The authority having jurisdictions, regulations, and interpretations of earthquake resistant architectural, mechanical, and the MEP. So just look that up if you're going to do a fire pump and get the requirements for fire pumps. I'll give you a little help there. In the seismic requirements, you can locate that on page 24, 23, and 24. It would give you details, and there's a block there, the listing of equipment and system components, fire protection, detections, and alarm systems. So system components, fire alarm panels, fire alarm wiring, emergency standby equipment and emergency components, emergency generators, automatic transfer switches. To name a few, seismic is required as well. Reference material for fire pump installation, NEP 20, also known as the standard for installation of stationary pumps for fire protection, an important guideline that helps ensure we have reliable source to water when there's a fire emergency. This standard provides clear rules about how to choose, install, and operate fire pump systems, making them essential for safety. Here are some main points it covers. The Fire Pump Basics NFP 20 outlines how to select and set up stationary fire pumps, including important aspects related to them electrically and mechanical parts. The standard discussion type, different types of pumps, such as pumps with rotating parts to move water, vertical shaft, turbine pumps, often found in deep wells. The power source, designs of the pump, those are some of the things that the NFPA 20 can help guide you with when you're looking into installing a fire pump. The importance of the NFP 20 in fire safety cannot be overstated. It helps ensure that fire pumps are ready to go when needed. Protecting lives and it helps ensure that fire pumps are ready to go when needed. Protecting lives and property by providing the necessary water for firefighters. Many local laws and regulation draw from NFPA 20, making it a key resource for establishing safe practices in fire pump installations. Designers, engineers, contractors, and installers use NFP 20 to ensure that fire pumps are built in high standards and industry best practice. NF 20 is a crucial resource for anyone involved in fire protection. It offers straightforward and detailed instructions on how to design, install, test, and maintain stationary pumps, ultimately enhancing safety during emergencies. As I conclude, when it comes to fire pumps, making sure they can count on consistent utility services or having a backup generator is important. Codes and regulations say that utility power is acceptable if it gets the green light from the authority having jurisdiction. But whether you can truly rely on that power can be a topic of discussion, as pointed out by the engineer of records. Not having a backup generator for a fire pump can raise significant concerns about the system reliability in emergencies. Decisions about these systems need to align with industry standards to ensure safety and dependability. It's essential for those working in electrical services to focus on the correct installation of critical safety equipment like fire pumps to guarantee they work well when needed. Planning and considering potential problems are critical because fixing wiring issues after the installation can be tough and costly. Checking the outage report from utility companies can help us understand how reliable the power source is. With a record of 3 years without outages being a strict requirement set by the authority having jurisdiction, ensuring that fire pump systems are reliable is vital for keeping people and property safe during emergencies. Following regulations and conducting thorough assessments are key to maintaining safety and lowering risks effectively. In summary, here are a few points to remember about the authority having jurisdiction policy: concerns, requirements, reliability check, evaluation process. Join me 2 weeks from now, May the 14th, as I answer questions from the electrical industry and homeowners. Let's work together to tackle any potential electrical safety concerns. Visit my YouTube channel, where I post short videos showcasing common mistakes in the electrical inspections. You can learn more about the best practices to follow and what to avoid when dealing with electrical systems. If you're interested in understanding more about electrical standards, check out the list of 60 best electrical podcasts. Feel free to reach out on social media with any questions, comments, or topics. You can find me on Facebook, Instagram, and YouTube under the name Ask the Lady Electrical Inspection. Alternatively, you can email me at asktheladyelectricalinspector@gmail.com for more discussions or to share your thoughts. Let's work together to keep our electrical system safe and up to code. Thank you for your time and have a great night.